Hello my dear students, welcome to Lakshya Karnataka YouTube channel, and your physics exam is next. And you are wondering, sir, I have not studied anything, I want to pass in the exam. So that's why I have bring you the best passing package ever possible, because if you study this passing package you can score up to 50 to 60 marks easily, but provided that obviously you score well in the MCQ part, because I am going to solve MCQs in this session, but the MCQs are not guaranteed. But 2, 3 and 5 marker questions are mostly going to come from this lecture, and those who want to revise along with me, don't forget to join me right now, and let us continue with the discussion. But before I start, just wanted to remind you the question pattern of the exam. So you have to answer 15 MCQs and 5 fill in the blanks. We are going to discuss today, we are going to discuss total 30 MCQs in this lecture, and obviously sufficiently enough 3 marker, 2 marker, 3 marker and 5 marker combined we are going to discuss 50 questions. Okay, so 30 MCQs and 50 questions from 2, 3 and 5 markers, so sufficiently enough. Watch this 2-3 hour video. If you have not prepared anything, then this is going to be a game changer for you, and you should be able to score well. And those who have studied, they want to revise, then also you can join me. Let's start with the lecture. First question: dipole moment is a vector quantity which is pointing from, so dipole moment is a vector quantity which points from negative charge to positive charge. Okay, dipole moment is a vector quantity pointing from negative to positive charge along the axis of the electric dipole, so option A is correct. Next, the electric potential due to a negative point charge at a distance r. So electric potential is given by minus kq by r for a negative charge, obviously, right? The charge is negative, so you have to consider the negative sign. So potential is negative and it's proportional to 1 by r, so it is negative and proportional to 1 by r. Next, the following are the statements related to self-inductance. The self-inductance of a coil depends on the geometry and on the permeability of the medium inside it. The self-inductance is a measure of electrical inertia and opposes the change in the current in the coil. So both statements are correct. Okay. So option C is correct. Make sure you read the options carefully, because first option is not the correct one. Here both statements are wrong. Okay, so make sure you put that in your head, that not always the order of the options will be remain same. Generally option A says both options are correct, but here option A says both options are wrong. So make sure that take care of that in the exam. Next, a ray of light is incident on a glass-air interface at an angle greater than the critical angle for the pair of media. Then the ray undergoes total internal reflection. Okay, this is the condition of total internal reflection. Light has to travel from rarer to denser medium. Denser to rarer medium, and the angle of incidence must be greater than critical angle. So here glass air interface means light is traveling from glass to air. Glass is denser, air is less denser, so that means denser to rarer medium condition is satisfied, and angle is greater than critical angle, so it must be total internal reflection. Statement based question: the resistivity of metals. Any statement based questions are actually HOTS question. Last statement based question and this one also are HOTS question. The resistivity of metals increases with the increase in temperature. Resistivity increases with increase in temperature. Resistivity is proportional to temperature. Increasing the temperature of the metals causes more frequent collision of the electrons. So electrons start vibrating more, they start to collide more, and as they start to collide more, their relaxation time decreases. Relaxation time decrease means resistivity increases. Okay, so resistivity is inversely proportional to relaxation time. More frequent vibrations means less relaxation time, and less relaxation time means more resistivity. Okay, both 1 and 2 are true, and 2 is the correct explanation, so option A is correct. Next, the Lorentz force is a force on a charged particle moving in a region containing both electric and magnetic field. Okay, both electric and magnetic field. Now it's a match the following question. Now in the match the following, always I say, if you don't you are not able to match everything, try to match at least few of them so that you can find which can be the correct answer. So here a self-induced EMF induced in a rod moving in a magnetic field, AC generator, transformer. These are the four options given. Here we have motional EMF, electromagnetic induction by changing the orientation of a loop. Now this one we know is AC generator. This one we know is motional EMF is the due to the moving rod in a magnetic field. Mutual induction, so transformer works under the principle of mutual induction, and the self-induced EMF then must be equals to back EMF. If you are not sure, try to match whatever is there, and remaining one you can figure it out. If not, then check that if the matches that you have done, is it unique or not. So SPQR, let's see, SPQR option A is correct. Okay, AS, BP, CQ and D with R. Next, move on. The average power dissipated in an AC circuit is maximum if there is an AC source connected only to pure resistor or the circuit is in resonance. Okay, inductor and capacitor does not consume any power, so power consumed by an inductor, capacitor or combination of inductor and capacitor always will be 0. Okay, so average power consumed in an inductor, in a capacitor or a combination of inductor and capacitor will always be 0. Okay, it is always maximum power will be dissipated if it is only a pure resistor. Next, the displacement current is due to flow of electrons, flow of protons, changing electric field, changing magnetic field. So displacement current is proportional to ID equals to epsilon naught d phi E by dt. Okay, so this is the changing electric flux, rate of change of electric flux, and rate of change of electric flux is basically changing electric field. Okay, so this is the displacement current. Next, statement number 1, the net magnetic flux, again another hot question. The net magnetic flux through any closed surface is 0. The number of magnetic field lines leaving the surface is balanced by the number of field lines entering it. Yes, both statements are correct, and obviously statement 2 is correct explanation. So in a magnetic field, the number of field lines, if you are considering the number of field lines which is entering, the same number of field lines will be exiting always, no matter how you enclose the thing. Now you might say, sir, if I only have a north pole inside it, what about that? In this case, you might say, sir, only field lines will exit. Yes, field lines will exit from the north pole, but inside the magnetic field lines will travel in the opposite direction. So no matter how many field lines are exiting, same number of field lines will enter through this, and they will the net magnetic flux through this surface will be 0. That's why magnetic flux is always 0 in a closed surface. Next, the electromagnetic waves with lowest frequency among the following. Lowest frequency will be radio waves. Okay, gamma ray has highest frequency, UV ray is next, microwaves is higher than radio waves, and radio waves is the smallest frequency. It has highest wavelength and lowest frequency. So lowest frequency is radio waves. Any combination of this will be given. You have to remember the table where you have to remember gamma ray, X-ray, UV ray, visible light, then infrared, then microwave, then radio waves. Okay, so this is the order for highest frequency to lowest frequency, and if you go from bottom to top, highest wavelength to smallest wavelength. Next, the current density is a vector quantity and its unit is ampere per meter square. Current density J is a vector quantity and its unit is it is given by I upon A. I is current, so ampere per meter square. Okay, area, A is area is meter square. Next, a straight conductor of length L is moving with a velocity v in the direction of the uniform magnetic field of strength B. The magnitude of the EMF induced between the ends of the conductor is. So here if you see that magnetic field is in the direction of the uniform rod, so rod is moving in this direction. Okay, magnetic field is also in this direction, so the induced EMF here will be 0. induced EMF will be 0. So rod has to move perpendicular to the magnetic field, so that there will be an induced EMF. If they are moving in the same direction, then induced EMF will be 0. It is not BVL, it will be 0. Next, an object of finite height is placed in front of a concave mirror within its focus. It forms. So an object is placed concave mirror within its focus. So this is the focal length. If the object is placed, it will form a virtual and enlarged image. It will form a virtual and enlarged image. Next, the ferromagnetic material among the following is copper, nickel, lead, calcium. So only nickel is the ferromagnetic material. Okay, copper is diamagnetic, lead, I think lead and calcium are paramagnetic. Okay, nickel is only ferromagnetic material. Nickel, cobalt and iron, remember these three names, they are ferromagnetic naturally. In a purely capacitive circuit, if the frequency of AC is doubled, the capacitive reactance will be. So in a purely capacitive circuit, the frequency of AC is doubled. So capacitive reactance is basically 1 by 2 pi F into C. So if you double the frequency, then capacitive reactance will be halved. Capacitive reactance will be halved. Get halved. Halved means half value. Okay, so initially if it was 100, now it will be 50. That is called halved. Getting halved means value becomes half of the previous value. Next, the power factor of a series LCR circuit is maximum. Power factor of a series LCR circuit is maximum when the circuit is in resonance, and the condition for resonance is XL equals to XC. So correct answer is option A. Remember this very interesting question. Power factor is maximum when the circuit is in resonance. Maximum value of power factor is +1. Which of the following phenomenon confirms the transverse nature of light wave? Polarization of light confirms the transverse nature of light, because only for transverse wave polarization can be observed. For any other type of wave, for longitudinal wave, obviously polarization is not visible or observable. Next, while both light and sound show wave character, diffraction is much harder to observe in light. This is because the light wavelength is smaller, sound wavelength is larger, so that's why it is difficult for us to observe diffraction in light. So wavelength of light is far from smaller compared to other waves. That's why diffraction is very less common in light wave. In our day-to-day life, if you obviously set up proper equipment, then definitely you can observe, but otherwise normally it is not observable because of the fact that light wavelength is far smaller. The gathering and focusing mechanism of light by eye lens is described by. Gathering and focusing happens by the wave principle, okay, wave nature of light, and absorbing and transmitting the information happens in the principle of particle nature. Okay, gathering and focusing, gathering by our iris and focusing onto the retina happens by the wave principle, and from retina till our brain the process is basically particle nature of light. Remember this. Okay, particle nature of light is basically from retina till brain. Okay, retina absorbs particle by particle and then it sends back to the brain particle by particle, but total overall principle of eye involves obviously both particle and wave nature. Next, the slope of stopping potential versus frequency in Einstein's photoelectric equation. So let's see. Einstein's photoelectric equation says that EV naught equals to h nu minus phi naught. So V naught equals to h by E nu minus phi naught by E. So if you see that the slope is h by E. So if you plot, this is y equals to mx plus c. So you know this is the intersection, this is the slope. Okay, this is x, this is y. So y versus x is the graph. So h by E is the correct answer. If they ask what is the value of intersection, value of intersection will be minus phi naught by E. minus phi naught by E will be the intersection value. So remember that as well. They might change the equation, they might change the question, but if you remember that, okay, I know this is the case that H by E is the slope of the equation from Einstein's equation, and the intersection is minus H by phi naught by H, then you should be able to answer that question as well. Phi naught by E, not H, phi naught by E. The alpha particles are helium plus 2 ion. Okay, alpha particles are basically alpha particle when you take 2 electrons out of the helium atom, then it becomes alpha particle. So basically it's the helium nucleus. You can say it is the helium nucleus, 2 protons and 2 neutrons. Next, according to Louis de Broglie, waves associated with orbital electrons are stationary wave. Okay, he came up with this idea to explain Bohr's atomic model. While explaining Bohr's atomic model, he said that, okay, the orbits which Bohr is saying they are static, electrons are not emitting any radiation because of the motion. That means it must be where the electrons are orbiting in a stationary, they are must be making stationary waves. So this is the wave pattern. Stationary wave means they has to merge it over here. Okay, so both waves must be merging over here, then only stationary wave is possible. Next, Mn and Mp represent mass of neutrons and protons respectively. If the element having atomic mass m and n neutron and z proton, then the correct relation will be, so m must be less than total mass of neutrons and protons, so the atomic mass must be less than that of the total mass of neutron and proton. So this is the correct relation. Next, radioactive substances emit alpha rays, beta rays, gamma rays, all of the above. So radioactive emission emits all of these radiations. Make sure if you see this kind of question, you do not forget all of the above option. All of the above option can be correct. So make sure that you have gone through all these options properly. A semiconductor doped with a donor impurity is, so donor impurity basically gives away electron. So gives away electron means the semiconductor has more number of electrons. Basically it's an n type. Donor is n type. Acceptor means it accepts an electron, then it will create an extra hole. That means it is a p type. P type means more number of holes. N type means more number of electrons. N stands for negative, P stands for positive. So positive type, negative type. Negative type means more electron has to be there. So that means it is doped with donor impurity. Also remember that be it a P type, be it N type, or be it a p-n junction, diodes, or any semiconductor, intrinsic or extrinsic, they are always electrically neutral. They do not have any excess charge. Okay, that is also a very common question. Next question. Which is the correct diagram of half wave rectifier? If you see here, we have 2 diodes. Obviously 2 diodes are not required for a half wave rectifier. This is the correct diagram for half wave rectifier. Okay, this here we are disconnecting with the with the capacitor. So this cannot be a half wave rectifier. This also cannot be a half wave rectifier. Okay, half wave rectifier is this. This is a filter. Okay, this is called a filter. Next, same filter like you filter water. Similarly, it filters out some part of the AC. N-type semiconductor is electrically positive, negative, neutral. So as I mentioned, be it N-type, be it P-type, be it P-N type, or extrinsic, intrinsic, semiconductors are always electrically neutral. Okay, in the equation AB equals to C, A is current density, C is the electric field, then B is very common, it will be resistivity. Now if you are wondering how did you came up with that, sir, so I will explain that. J is equal to sigma E, so E is equal to J upon sigma. Okay, or 1 upon sigma is resistivity. Resistivity and conductivity are cousin brothers. Okay, so if one is high, another one will be low. Okay, so they are not directly related, but they are inversely proportional. So that's why if J by sigma is basically rho into J. So here this is given as C, this is given as A. Okay, so this must be B. So resistivity. It is resistivity or specific resistance. Remember, resistivity is also called specific resistance. A rectangular coil carrying current is placed in a non-uniform magnetic field. On the coil, the total force is non-zero. Force is 0, torque is 0, none of these. Force is non-zero. If it is a non-uniform magnetic field, remember that in non-uniform magnetic field, a dipole always experiences force as well as a torque. If the field is uniform, only torque is there, force is 0. Okay, torque is not there, not 0. Torque will not be 0 in any case. Okay, so if it is a uniform magnetic field, that force is 0. If it is non-uniform, because in this question it is mentioned it is a non-uniform magnetic field, so and a current carrying coil can be considered as a dipole, that means it is a the force is not 0. Now before I continue, I just want to remind you that our KC30 batch registration already started, and many students have already registered. By the time I am taking this lecture, more than 200 students have already registered for KC30. Maybe the number will increase by the time you are watching it. So don't forget to register for it, and the price is still 2499. And for more information about the course, you can click on the link given in the description section and decide yourself. Now remember that the batch will start from 21st of March, which is less than 15 days after your physics exam. Now KC30 batch, you will get 30 days live online crash course. KCET previous year questions will be discussed in thoroughly. Complete syllabus will be revised, PU1 and PU2. Also chapter wise KCET PYQs will be given to you in a test format, which is very unique, and you are getting 10 full length KCET mock tests. Okay, and the price for this is 2499. Also we have KC30 plus, where you are getting KC30 and everything of KC30 plus ABHYAS KCET test series. Okay, so that will also available. If you want to purchase, that is also available. You can click on the link given in the description section and decide yourself. Okay, and don't be late, because as you know, the prices might go up, and also the seats may fill up very soon, so you may not get a chance to enroll. So enroll today so that you don't miss out on this. Now next, state Coulomb's law in electrostatics and explain the in case of free space. I don't get the case Coulomb's law. And one more point that might ask, that vector form, both are super important. Okay, both question comes from almost every year. Okay, either Coulomb's law or vector form of Coulomb's law, both of them are very important. And if the question came in last year, you're thinking that, oh, this question came last year, it will not come this year. No, for Coulomb's law it is not the case. It can come even it came last year, because it is coming every year. Okay, either there will be a MCQ, or there will be a 2-marker, or there will be a 3-marker from this chapter. The law states that the electrostatic force between 2 point charges is directly proportional to the product of magnitude of the 2 charges and inversely proportional to the square of the distance between them. The force acts along the line joining the charges. Now if they ask you only simply explain in terms of charges kept in the space, then you have to mention, let us consider 2 charges Q1, Q2 kept in the space, then the force between them will be F equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. You don't need to give the vector form for explain the case for free space. You don't need to add the vector form. But if they ask you only write and explain Coulomb's law in vector form, remember you have to start from this equation, Coulomb's law in vector form. You don't need to write the statement in that case, but the vector sign has to be there. Okay, all the terms has to be mentioned properly. F21 is the force acting on second charge due to first charge. Q1, Q2 is point charges. Epsilon naught is permittivity of free space. R is the distance between Q1 and Q2. R cap 21 is the unit vector pointing from Q1 to Q2 along with the diagram. So for Coulomb's law in vector form, the diagram is compulsory. Don't make mistake. I am telling you, marks will be deducted if this question comes and if you forget to draw the diagram. So Q1, Q2, R21 is directed from 1 to 2 and R is the distance, and the force acting on this is given by F21. If you have some time, you can add this as well and you can say F21 is equals to minus F12. This is optional, but the diagram and the naming of these forces are very, very important. Don't miss out on that. Now let's move on. Derive the expression for torque on electric dipole placed in a uniform electric field. This question, if you have not prepared, you can skip, but this question is repeatedly coming in your model papers. Never came in the board exam, but it is there in your model paper repeatedly, and the derivation is simple. If it comes, it will be a 3-marker derivation. Okay, suppose we have a positive charge, this is a negative charge, but skip it on your own risk. I will not recommend to skip it. If you have not studied or if you do not have enough time to prepare, then you can skip, otherwise I will not recommend that. Now in the electric field, what happens is that the positive charge experiences a force in the direction of electric field, the negative charge experiences a force in the opposite direction, but the magnitude will remain same. So force on the positive charge will be equals to force on negative charge in terms of magnitude, and this is F minus, okay, this is F suffix minus, and that force will be given by Q into E. Okay, that force will be given by Q into E. Now if the dipole makes an angle theta with the electric field, then if you draw a perpendicular distance, this will be alternate angle, this will also be theta. Now the total distance of the dipole is say 2L, then this distance will be 2L sin theta. Okay, this distance will be 2L sin theta. You have to show that in the diagram itself. Now torque acting is given by you can take any of the forces and the distance between them, that is 2L cos sin theta, 2L sin theta. So the perpendicular distance you have to consider, not the any distance. Okay, not this distance but the perpendicular distance between the forces. Okay, torque is always defined by two parallel forces acting on a same object but at different positions, then magnitude of any one of the forces times the distance between the forces gives the torque. That is the definition. Okay, torque, sometimes it is also called couple, right? So this will be equals to Q into E into 2L sin theta, or Q into 2L into E sin theta. Now Q into 2L is called the dipole moment, so it will be PE sin theta. Okay, now vectorially this can be written as torque equals to momentum into electric field vector. Okay, this is the expression for torque. Very simple, easy derivation. You have to write a little bit explaining the steps, that's it. Okay, so let us consider a dipole of charge Q and minus Q. Okay, the distance between them is 2L, kept in the electric field E as shown in the diagram. Okay, and then mention the force acting on the positive charge and negative charge will be same magnitude wise, even though the direction is opposite. Okay, now if the dipole makes an angle theta with the electric field, then the perpendicular from plus Q to minus Q, the perpendicular distance between plus Q and minus Q will be given by 2L sin theta, and hence the torque acting between them is given by this. Then you do this mathematics. Small writing you have to do. Okay, obviously 3 marks is there. Now next, write any 3 properties of electric charge. Another very common important question. It can be asked two properties as a 2-marker, 3 properties as a 3-marker. So additivity of charges, just do not write the properties, write at least one single line explaining that. Charges can be added algebraically. Okay, if you can give example, very good. If you cannot, at least write the basic meaning of the statement. Quantization of charges, all charges are integer multiple of smallest charge, small e. Okay, small e is the charge of an electron, obviously. Conservation of charges, total charge in an isolated system is always conserved. Okay, so these are the 3 properties. Next, write 3 properties of electric field lines. Another common important question, again 2 mark, 3 mark, both is possible. Electric field lines may start from positive charge and end at negative charge. 2 electric field lines are never intersect each other. Electric field lines do not form any closed loop. So these are the 3 very important properties. Next, What is an equipotential surface? What will be the shape of the equipotential surfaces corresponding to a single point charge? So any surface which has same electric potential at every point is called an equipotential surface. The shape of the equipotential surface is spherical for a single point charge, and this should be accompanied by a small figure where you have to draw concentric circles. Okay, now let us continue. Write two properties of equipotential surfaces. Again, 2 mark, 3 mark, both is possible. I am mentioning two properties as it is given in one of your model paper, but it can be a 3 marker question as writing 3 properties as well. Okay, no work is done moving a test charge over an equipotential surface. Electric field is always normal to the equipotential surface at every point. No two equipotential surfaces can intersect each other. So these are the 3 very common properties. On what factor does the capacitance of a parallel plate capacitor depends? So we know that it is basically given by C equals to A epsilon naught by D. Sometimes they might ask you expression for capacitance in air and explain the terms. So that is also possible. That question also came in the past, but that is much easier. Obviously you have to write this expression and you have to explain. C is capacitance, A is area, epsilon naught is permittivity of free space, permittivity. Okay, permittivity of free space, and D is the distance between the plates. So obviously we can see that C is directly proportional to area, so capacitance is directly proportional to area, and it is inversely proportional to the distance between the plates. So this is the capacitor plate. So suppose the area of the plate, area, because it's not a 2-dimensional thing, it's a 3-dimensional thing, right? So it's a plates. So plates means it has to have some area. So this is the area. Okay, and the distance between the plate is D. So the area of the plates and the distance between the plates inversely proportional to the distance and directly proportional to area. So higher the area and smaller the distance, more is capacitance. Next, state and explain Gauss's law in electrostatics. Very common question. It can be asked as a separate 2 marker question, 3 marker question, or it can be asked as a question before a 5 mark derivation. State Gauss's law and hence prove. Okay, so this is the common answer for both questions. Okay, Gauss's law states that the total electric flux passing through a closed surface is equal to 1 by epsilon naught times the net charge enclosed by any closed surface. Now here you have to draw a diagram saying that, okay, suppose we have a closed surface and the charge enclosed by them is say Q enclosed. Okay, the flux coming out of the surface is say phi, then phi is given by Q enclosed upon epsilon naught, or if the electric field from the surface is given by electric field E, then E dot ds can be written as Q by epsilon naught. Okay, and here is the total surface, and write it as Q enclosed as the total charge enclosed by the surface. If it is 1, 2, 3, 4, the Qn will be addition of all the charges, right? Next, obtain an expression for effective capacitance of 2 capacitors connected in series. Now parallel one came last year twice in the first paper and paper 2. Both papers had same question, parallel combination. So parallel combination, in my opinion, may not come. If you have time, if you get time, practice the parallel one as well. If any question is coming from based on this, my guess is that series is more important than parallel one. So series one I am doing today's lecture. Okay, parallel one you can practice if you get some time. Parallel one, series one, both are will be a 3 marker question, not a more than 3 marker. Okay, so here we have 2 capacitors, C1 and C2. They are connected in series. Now remember, in series the total charge passing in the circuit should be same, whereas voltage will be different for different capacitors. Suppose the voltage across this capacitor is V1 and voltage across this capacitor is V2. So if you take a multimeter or a measuring device, put it across this capacitor, you will get the measurement V1, and if you do the same for C2, you will get the measurement V2. They are not same. Okay, now what is an equivalent circuit? Equivalent circuit means you replace this capacitor using a single capacitor, which can be real, which can be virtual, but the value of everything else should remain same. Now if you see that C equivalent, the charge flowing in the circuit should remain same. Okay, only thing that should change is the voltage. Now in the C equivalent, the voltage of the battery should be same as the capacitor plates. So capacitor plate will have the same voltage as this battery that is applied. Okay, so now this is the voltage for C equivalent. Now you have to use the law, that is Q equals to C1 V1. Q equals to C1 V1, or V1 equals to Q upon C1. Charge is same. Similarly, we can say that similarly V2 will be Q upon C2. As I mentioned, charge is same, so V2 will be Q upon C2. For equivalent circuit, V will be equals to Q by C equivalent. For equivalent circuit, only Q is same, C equivalent is the equivalent capacitance, but the total voltage is this. Now from conservation of energy, the total voltage V must be equals to V1 plus V2. Okay, so V across this battery should be equals to V1 plus V2. Now this V is equals to given by this, so we just need to put these values. So Q upon C equivalent equals to Q upon C1 plus Q upon C2. Okay, obviously Q will be common, and we get C equivalent equals to 1 upon C1 plus 1 upon C2. This is the expression for parallel combination of capacitors, right? Now let's move on. Derive the relation between electric field and electric potential due to a point charge. Now this is also very important derivation, 3-marker derivation, okay, from this chapter, and this might be coming in this year's paper. This did not came last year, so there is a high chance this question will be coming this year's paper, so do practice it. For that, first of all, you have to draw the equipotential surfaces like this, okay, one surface like that. You cannot show this dotted one, you plot one surface, then we plot one more surface in the top, okay. The potential of this is V, potential of the top one is V minus delta V, okay. The distance between them is delta L. Electric field is pointing from A to what's the B plane, okay, from A plane to B plane, okay. Now if you want to, if you take a small charge, say Q, and if you want to move it from this point A to the point P, then how much work you have to do? Now this work you can calculate in two ways. One is by the definition of work in electric potential, and in mechanical way as well, and those both of the work should be same. So first we will calculate using electric potential process. So how to do that? Electric potential, we know that the work done is given by V final minus V initial into the charge that you are carrying, that is the work done, okay. Work done is given by final potential minus initial potential into the charge that you are carrying. So what is the final potential? Final potential is V minus delta V. The derivation that I am doing is the shortcut way, okay, without much difficulty. So it will be Q into delta V. This is the work done when you are moving from A to P. Okay, now mechanical work done. What is mechanical way? Mechanical way, you have to calculate the force. Now these two charges are separated by a small distance delta L. The distance is very small, so electric field E is almost constant between these two plates. So what is the force acting on this charge? Force acting on this charge is Q into E. So force is Q into E. Now how much work you have to do? The work that you require to do is equals to the force into the displacement that is there, okay. So because the work is being done by the electric field itself, there is no negative sign, okay. So work done is given by F into delta L, so which is given by F is Q into E into delta L. Now both of the work must be same, so this is equation 2, this is equation 1, so both work has to be same. So both work has to be same means minus Q into delta V must be equals to Q into E into delta L Q cancels, and you get E equals to minus delta V by delta L. This is the electric field. Expression for electric field, the negative sign signifies that electric field points from higher potential to lower potential. Okay, so basically as the distance increases, V is decreasing. Okay, so electric field always points from the lower potential to higher potential, and in the direction where the electric potential decreases the steepest. Steepest means the shortcut distance, okay, the perpendicular distance. Okay, there can be, it can decrease in any other direction as well, but this is the smallest distance. So electric field directs from lower to higher in the direction where the electric potential decreases the steepest. Okay. Write the expression for drift velocity in terms of current. Explain the terms used. So drift velocity is given by I by NEA. I equals to NEA VD. This is one of the equation I always tell my students to remember, one of the most fundamental equations. I equals to NEA VD, and VD equals to I by NEA. Now here VD is drift velocity, I is current in conductor, number density of electron is given by N, E is charge of an electron, A is the area of cross section of the conductor, right? Now define the drift velocity and mobility of free electrons in conductors, or define mobility, mention its SI unit. Both can be possibly come. So drift velocity is the average velocity with which the electrons drift under the influence of an electric field called drift velocity. What is mobility? The mobility of free electrons is defined as the drift velocity of electron per unit electric field applied. The SI unit of electron mobility is meter per second, Newton per Coulomb is important. Okay, so drift velocity, mobility is given by drift velocity per unit electric field. Now drift velocity's unit is meter per second, and electric field is Newton per Coulomb. Okay, electric field's unit is Newton per Coulomb. So those who have forgotten it, so meter per second, and then Newton was in division, so it will be -1, and Coulomb was division of division, so it will be Coulomb to the power 1. So this is the unit of mobility. So if you forget, if you remember this expression, you can find the unit as well. Okay, so this can be tricky if you don't know the answer. Mention two limitations of Ohm's law. Very common question. Okay, Ohm's law applicable only if all the physical conditions remain same. Ohm's law is not applicable at very low and very high temperature. Ohm's law is not applicable to non-ohmic conductors like semiconductors or valves, okay, discharge valves. Name two factors on which the resistivity of a wire depends. Resistivity of the wire depends on the material of the wire and the temperature. Okay, these are the only two things that resistivity depends. Next, when does a current carrying conductor placed in an uniform magnetic field experience maximum force, minimum force? When the current flowing perpendicular to the direction of magnetic field, it experiences maximum force, and when the current is flowing in the direction of the magnetic field, force is 0. Okay, so current carrying wire is given by BIL sin theta. So if theta is 90 degree, force is maximum. If theta is 0 degree, force is minimum. 90 degree means perpendicular direction, 0 degree means same direction. Next, derive an expression for angular frequency of revolution for a charged particle moving in perpendicular to a uniform magnetic field. Obtain an expression for the radius of the circular path taken by a charged particle moving perpendicular to a uniform magnetic field. Now, when a charged particle is moving in a circular path, okay, there are two forces that is acting, not two forces, actually only one force is acting, which is the Lorentz force, okay, that is QVB. The Lorentz force is given by QBV. Now, to maintain its circular motion, okay, this Lorentz force has to supply the required centripetal force. Centripetal force is not something which is already there, okay, it has to be supplied by something. For example, Earth is rotating around the sun, okay, and for this rotational motion there has to be a centripetal force required. Now who is supplying this centripetal force? The gravitational force between Earth and sun actually providing the required centripetal force. Now if the gravity is not providing the required centripetal force, obviously the circular motion would not be possible. Either the radius has to change, or earth will move in a straight line into the space, we don't know where, and me never had existed without this. Okay, so thankful for the centripetal force provided by the gravitational force. Okay, similarly, when a charged particle is moving in a circular motion, the required centripetal force is provided by the Lorentz force. And what is that centripetal force? Centripetal force is given by mv square upon r. This has to be equal. If it is not, the radius has to change. If it is not, the circular motion may not be possible. So based on that, if it is not sufficient, it will rotate in a different radius. If it is more, it will rotate in a closer radius. Okay, so they has to adjust such a way that these two forces becomes equal. Otherwise, it is not possible. Remember that for any circular motion related question, if the object is rotating in a circular motion, some force is present which is providing the required centripetal force. So this is QV, V cancels, one V cancel, not all. So you can calculate the radius. So radius is directly calculatable, mv by QB. Okay, if they ask you to calculate the radius, this is just 2 marker question. Okay, if they ask you calculate the omega or the angular frequency, okay, that is a 3 marker question. Why? Because this requires little bit more calculation. So mv by r equals to QB. So we'll start from here. mv by r equals to QB. One V cancels. These two V's are same. Okay, these two V's are same. That's why one of the V's got cancelled. So now V equals to QB r by m. QB r by m. Now the relationship between linear velocity and angular velocity is given by V equals to r omega. Okay, omega is angular velocity, angular frequency. That is equals to QB r by m. Okay, so obviously r gets cancelled and we get angular frequency equals to QB by m. Okay, QB by m is the angular frequency. Now if they ask you to calculate the real frequency is very simple. Omega equals to 2 pi f. So real frequency is omega by 2 pi. So it will be 1 by 2 pi QB by m. And time period is exactly invert of that. So 2 pi m by QB is the time period. Okay, so these all questions can be possible from this same question. Time period, frequency. If they ask only frequency, you have to find this. If they ask time period, obviously you have to find this. Okay, now shortcut for finding time period is that time period is 2 pi by omega. So omega you calculate, then you can directly calculate time period or directly calculate frequency. Frequency is omega by 2 pi and time period is 2 pi by omega. Okay, now next, what is Lorentz force? Write its expression and explain the terms. Very important question, very important question. Force acting on a moving charged particle in the presence of electric and magnetic field is called Lorentz force. So F is equal to Q into E plus Q into V cross B. Here Q is charge, E is electric field, V is velocity of the particle and B is the magnetic field. Okay, so remember, force acting on a charged particle in the presence of electric and magnetic field both has to be present. Next, how can a galvanometer be converted into a voltmeter? Explain with the diagram. One of the conversion is definitely going to come, mostly. Okay, there are few years where Lorentz force came, not the conversion. So obviously all the questions are important. So first is galvanometer to voltmeter. Okay, so galvanometer to voltmeter conversion is done by applying a high resistance in series. But first you have to mention that a voltmeter should have a very high resistance as it is connected in parallel in the circuit. Okay, so because it is connected in parallel, okay, it should have a very high resistance, otherwise the overall balance of the circuit will deviate. Okay, ideal galvanometer should have infinite resistance. Practical galvanometer should have a high resistance. A galvanometer is converted into a voltmeter by connecting a suitable high resistance in series with it. This is the way to overall resistance of the galvanometer remains high. Okay, so this is the diagram, and you also have to write that the voltage that you are measuring is Ig into G plus S. Okay, this is the voltage that you are measuring in the voltmeter. Next, how can a galvanometer be converted into an ammeter? Explained with the diagram. An ammeter should have a very low resistance as it is connected in series in the circuit. So again, if you connect something in series, the resistance should be low. If you are connecting something in parallel, the resistance should be high. If you are connecting something in series, the resistance should be low, so that the original circuit does not change. The original balance of the circuit does not change because of the connection of these devices. Okay, that's why the we do not use or simple galvanometer, we use ammeter or voltmeter. Those are specific kind of measuring devices. Okay, now how to do that? This is achieved by connecting a suitable resistance S in parallel called shunt. Okay, low value resistance, very important, low value resistance or low resistance, okay, with the galvanometer. This way the overall resistance of the ammeter remains low and the galvanometer is converted into an ammeter. Now here you have to find the current that you are measuring. So I equals to Ig into Ig into G plus S by S. Okay, so this is the expression for current. If you forget it, you can find it. Ig into G equals to I minus Ig into S. Okay, so voltage drop should be same across both of the component. So Ig into G equals to I minus Ig. So when we were students, this derivation used to come. Okay, show that the current passing through a ammeter is this. Okay, so that derivation is no longer there, but when we were students, this was to come. Okay, from here we can say that Ig plus Ig into G plus Ig into S equals to I into S, or this is the expression. Okay, remember S, single S will be in division and G plus S should be in the top. Okay, this is the current that is being measured. Okay, this is the current that is measured. Do not find Ig, find I. Find I. I is the current that is measured in the galvanometer or in the ammeter actually. Next, state and explain Biot-Savart's law. Write its vector form. So state and explain is only simple explanation, where the diagram is compulsory. If they ask you vector form, you have to explain the terms as well. Okay, so vector form and explain the terms, that is also possible for this question, and also the same question might be asked as state and explain Biot-Savart's law, or write Biot-Savart's law in vector form and explain the terms. Both are possible. So in explanation case, the diagram has to be drawn, this kind of curved diagram. Okay, I hope everyone practiced it. The magnitude of magnetic field at any point due to a current carrying element dl is given by directly proportional to the strength of the current. So it is obviously higher the current, more magnetic field. Directly proportional to the length of the current, directly proportional to the sine of the angle between the current element and the line joining given the midpoint and the current element, and inversely proportional to the square of the distance between them. Now the magnetic field in vector form, it is given by dV equals to mu naught by 4 pi I into dl cross B, okay, divided by R square. This is the vector form of Biot-Savart's law. There is no sine theta, because in vector form sine theta is actually inside the cross product. Okay, that's why sine theta is hidden in this equation. Okay, do not write a sine theta over here. I have seen students, they are writing everything right, but they write one sine theta over here, which is not correct. Also, it is not B cross dl, it is dl cross B. The order of cross product is very, very important in case of when you are using two cross product. Okay. Next, write three differences between diamagnetic, paramagnetic or ferromagnetic materials. Actually, this is a three different questions: diamagnetic, paramagnetic, diamagnetic, ferromagnetic, and paramagnetic, ferromagnetic. All three difference can come. So if you study one single question, 3 answers you can possibly write. So 3 questions is possible from this question, and this is also very, very important question. It did not came last year, so there is a high chance this might come this year. Okay, so property, whenever you are writing a difference table, try to write this way. This is a very effective way. First is the property or the quantity that you are trying to write. Next, the materials which is given in the question. Okay, you do not write the entire table. Obviously, if it is only diamagnetic and paramagnetic, you do not need to write this. If it is say diamagnetic and ferromagnetic, paramagnetic you can hide. If it is para and ferro, you can hide the diamagnetic, obviously. Okay, so based on the question, you need to obviously do not write the entire table, because sir gave us the 3 table and sir mentioned us that okay, 3 questions I have to write. So don't do that. Adjust it according to the requirement. Okay. So magnetic behavior, these are weakly repelled by magnetic field. Paramagnetic, these are weakly attracted by magnetic field. These are strongly attracted by magnetic field. Ferromagnetics are strongly attracted, paramagnetics are weakly attracted, diamagnetics are weakly repelled. Okay, magnetic susceptibility less than 0, small but less than 0, small but greater than 0, and it is very, very greater than 0, very high value and positive. Okay. Effect in magnetic field, induces a magnetic field in the opposite direction, induces a magnetic field in the same direction, induces a strong magnetic field in the same direction. Okay, so paramagnetic and ferromagnetic, they have some similarity, whereas diamagnetic is different from all of them. Now remember, there is one question that came in the past, that which of the properties is common. Obviously diamagnetic is common among all the properties. Okay, now let's move on. Write any 3 properties of magnetic field lines. Another important question. Magnetic field lines form continuous closed loops. The tangent to the field line at a given point represents the direction of the net magnetic field. That point, larger the number of field lines crossing per unit area, stronger is the magnitude of the magnetic field. The magnetic field lines do not intersect. I have given 4 options. You can remember any 3 of them. Okay. Now next, state and explain Gauss's law in magnetism. Very important question. This also has came in the past. Gauss's law of magnetism is the net magnetic flux through any closed surface is 0. So B dot ds equals to 0. What is the significance? Significance is that magnetic monopoles do not exist. That is, magnetic field lines always form closed loop. Closed loop means the incoming flux is equals to outgoing flux. That's why that is equals to 0 always. Next, state Faraday's law and Lenz's law of electromagnetic induction. Out of these, Lenz's law is asked most of the time. Faraday's law, maybe it came some older times, recent, not of recent, but you should prepare both the laws. And if they ask you what is the significance of Lenz's law, then you have to mention that Lenz's law is basically based on the conservation of charge principle. Okay, conservation of energy principle. Okay, so Lenz's law is based on conservation of energy principle, and Faraday's law is basically a law. The time rate of change in magnetic flux through a circuit induces magnetic field in it, induces EMF in it. Okay, electromotive force, that is battery or voltage. Okay, Lenz's law, polarity of the induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produces it. Combining both of them, you can write induced EMF is equal to minus d phi by dt. Now the d phi by dt terms comes from Faraday's law, and this minus sign comes from Lenz's law. Next, mention any 2 factors on which the self-inductance depends. Now self-inductance is directly proportional to the square of the number of turns per unit length. Self-inductance is directly proportional to the cross-sectional area of the solenoid. Self-inductance is directly proportional to the length of the coil. Now here, remember that you can mention all of them into, it depends on the geometry. And this is number 1, and number 2 is it depends on the material inside. Okay, there has to be a material inside as well. So mu r is there, so it will depends on the material of the core. Okay, do not write this. This is the old answer. I forgot to change it. Why I am saying that? Because this expression is not 100% accurate, because you can rewrite this equation. This is not wrong. This equation is correct. Okay, but this equation can be rewritten as L equals to mu naught mu r, okay, n square by L into A. Here n is the total number of turns, here number of turns per unit length. Okay, number of turns per unit length and area is correct. This one is based on how you are writing the equation, this statement can change. Okay, number of turns per unit length is correct. Okay, area is correct, but this length part can be dubious. If you write it like this, it is proportional to L. If you write it like this, it is inversely proportional to L. So avoid this. Mention geometry of the coil and the material of the core. Material of the core is basically this one. Okay, relative permeability. Relative permeability is basically the permeability of the material that is placed inside the solenoid. Okay. Derive the expression for motional EMF induced in a straight conductor moving perpendicular to the uniform magnetic field. So this is the uniform magnetic field which is perpendicular into the page of the paper, and there is a rod which is moving perpendicular. Okay, so the velocity vector and the magnetic field vector are perpendicular. So remember that they has to be perpendicular. If they are in the parallel direction, induced EMF will be 0. We solved one MCQ like that, right? Few moments back. So now what you have to do, you have to find the induced EMF. How you can do that? So here it is the length of the rail. It is the width of the distance from this end. Okay, now remember that you have to explain the diagram briefly. That let us consider a wire PQ which is moving along a rail shown in the diagram PQRS. Okay, the area of PQRS you have to calculate. What is the area of the PQRS? Area of the PQRS is given by length into breadth, that is L into X. Okay, so this is the first stage. Now the magnetic flux linked with this loop, is given by phi equals to the magnetic field into area. Magnetic flux linked is always given by B into area. Okay, now what is B is constant, obviously given here. Magnetic field is given. If it is not given, you have to show that in the diagram. Magnetic field is B. Okay, now what you have to do, B into area is L into X. Okay, now what is the induced EMF? Induced EMF is given by minus d phi by dt. Okay, d phi by dt with a minus sign. This is the, according to Lenz's law, there will be negative sign. This is the induced EMF. Okay, now you have to differentiate B into L into X. Now obviously magnetic field is constant, it is given in the question. So magnetic field is constant, the length is fixed, it is not changing. Only thing that is changing with time is this X, because it is moving, so the X is decreasing. Okay, it is moving, X is decreasing. That means we can write minus B into L into dx by dt. Okay, because only X is changing with time. B and L are constant, so that's why they can come out of the differentiation, right? Now what you have to do, you have to figure out what is dx dt is. Dx dt is basically rate of change of distance. Rate of change of distance is velocity. Now what it is happening is that X is decreasing. As the rod is moving in this direction, value of X is decreasing. Value of X is decreasing. That means the velocity of the rod can be written as minus dx by dt. Why minus? Because X is decreasing. You can mention that X is decreasing. Okay, so it will be B into L into minus dx by dt, and minus dx by dt is the velocity of the rod, so it will be B L V. This is the expression for induced EMF. This is the expression for induced EMF. You have to draw the diagram. You have to draw the diagram, briefly explain the diagram, and do the derivation. Derivation is very easy, simple, right? And this is also super important question. Next, explain briefly the coil-magnet experiment to demonstrate the phenomena of electromagnetic induction. This question also has come in the past. So in this case, this diagram is compulsory, where you draw a coil, a magnet is moving towards the coil, there is a galvanometer which is showing some deflection. Okay, and magnetic field lines are also has to be shown properly. When a magnet approaches the coil, the galvanometer needle deflects, indicating a current is induced. When the magnet is pulled away, first of all, let us say that the experiment is shown as shown in the diagram. Mention that the experiment is as shown in the diagram. When the magnet approaches the coil, from now you start writing this. Okay, when the magnet is pulled away, the needle deflects in the opposite direction. This is very important. You should not forget this. Showing that the current reverses, the direction of the current reverses. No current is induced when the magnet is stationary relative to the coil. Okay, this is the statement, and then you have to explain or conclude it. A current is induced in the coil when the magnetic flux through the coil changes. Magnetic flux means this number of field lines linked with the coil changes. Okay, this confirms Faraday's law of induction, and the direction of the current follows Lenz's law, opposing the change in the magnetic flux. Okay, now let us continue with the discussion. Mention 2-3 uses or applications of Polaroids. This is also important question. This can be asked along with the 5-marker question, where they will ask you find the law of reflection using Huygens principle, and then uses of Polaroids. That is also common. So Polaroids are used to control the intensity in sunglasses, window panes, etc. Polaroids are also used in photographic cameras and 3D movie cameras. They are used in 3D movie glasses as well. So camera are used to record movies, and that movie, to watch that movie, you require 3D glasses. So both cases 3D glasses are required, or Polaroids are required. Okay, so record a 3D movie. You may have heard that James Cameron is recording movies using 3D cameras, and then it is being projected in a 3D theater, and to watch that 3D you require a special glasses, which is basically all of them are Polaroids. Next, mention Einstein's photoelectric equation and explain the symbols. So h nu equals to 5 plus half mv square. H is Planck's constant, nu is frequency, phi is work function of the metal, m is mass of the electron, v is the velocity of the ejected electron. Okay, so these are the very common thing. Sometimes you might this is work function, sometimes is written as phi naught. So let me write in terms of phi naught. This is one form. There are other forms as well. You can write other forms of Einstein's photoelectric equation as well, but this is one of the standard form that I have given you here. Okay, EV naught equals to h nu minus phi naught is also acceptable. If you, as long as you are explaining the terms properly, any one of the form is accepted. Generally there are 3 different forms. Any one form is acceptable as long as you are explaining the terms, right? Now let's move on. Write 3 features or properties of nuclear forces. Okay, so nuclear force is much stronger than Coulomb force acting between the charges, or the gravitational force between the masses. Nuclear force between 2 nucleons falls rapidly to 0 as their distance is more than few femtometers. Nuclear force is a short range force. The nuclear force between neutron-neutron, proton-neutron and proton-proton is approximately the same. The nuclear force does not depend on the electric charge. So these are the properties. Okay, next, write 3 limitations of Bohr's atomic model. The Bohr model is applicable to hydrogenic atom only. It cannot be extended to even atoms having 2 electrons, such as helium. While Bohr model is correctly predicts the frequencies of light emitted by hydrogen atom, the model is unable to explain the relative intensity of the spectrum. The model does not explain the fine structure. Fine structure means when you are observing a spectrum, if you apply any external electric or magnetic field, okay, the line splits into more than one line. Okay, one is called Zeeman effect, another one is called Stark effect. Okay, and that cannot be explained using Bohr's law or Bohr's atomic model. Okay, Zeeman effect, Stark effect was observed, but the theoretical explanation came much later than this. So this is one of the problems with Bohr's atomic model. What are coherent sources of light? Give one example. Coherent sources of lights are the light sources that emit light wave in the same frequency, wavelength and phase, or have constant phase difference. So that is coherent sources light. Example is laser light. Next, state Huygens principle in wave theory of light. Huygens principle states that every point on a wavefront acts as a source of spherical wavelets. The sum of these wavelets form new wave front. Okay, so this is the diagram you have to draw along with Huygens principle. Give Einstein's explanation of photoelectric effect and write Einstein's photoelectric equation. Now photoelectric equation we have already written, so let me give the Einstein's explanation. Sometimes it can be asked only explanation, 2 explanation or 3 explanation based on the marks. Einstein suggested that each photon of light has energy proportional to its frequency given by E equals to h nu, where h is Planck's constant. When light shines on a metal surface, photons transfer their energy to electrons in the metal. Any energy from the photon exceeding the work function becomes the kinetic energy of the ejected electron. Okay, so this is the 3 points that was important to Einstein. Okay, and this is a very common question as well. Next, how can a semiconductor diode be forward biased? What happens to the width of the depletion region when the forward bias voltage is increased? Again, a 3-marker question. A semiconductor diode is forward biased when you connect the positive terminal of the power source like a battery to the P side of the diode and the negative terminal of the battery to the N side of this diode. This setup helps to overcome the potential barrier created by the depletion region and allows the current to flow through the diode. Okay, now this is this question alone is a 2-marker question. Now from this chapter we are expecting a 2-marker question, not a 3-marker question. But if they ask you what happens to the depletion region when you increase the potential, then you have to answer this in case of forward bias, in case of reverse bias. That is also possible as a 2-marker question. So if you increase the forward bias voltage, the depletion region decreases and slowly disappear. Exactly opposite happens in case of reverse bias. Okay, the depletion region width increases and there is no current flowing in the diode. Next, write 3 differences between intrinsic semiconductor and extrinsic semiconductor. Okay, definition: pure elemental semiconductor with no impurities, semiconductor doped with a small amount of impurity to improve its conductivity, charge carriers equal number of electrons and holes, unequal number of charge carriers. Okay, based on whether it's a p type, more number of holes, or n type, more number of electron is possible. Okay, conductivity: low conductivity at room temperature, high conductivity due to doping, which increases the charge carriers. Next, give Cartesian sign convention used to measure distances and heights in spherical mirrors. Okay, possibly this is the important question. Possibility of coming this question is very high. So this diagram you have to draw the diagram. The diagram itself is self-explanatory, but you have to draw the diagram properly, use proper way to draw the diagram, and mention this: all the distances measured along the positive x-axis are positive, all the distances measured along the negative x-axis is negative, all the distances along the positive y-axis is positive, all the distances along the negative y-axis is negative. So mention this is negative x. Okay, you mention the y-axis as well. Okay, this is positive y and this is negative y. Okay, mention everything. Now next, move on. Show that the focal length of spherical mirror is equal to half of its radius of curvature. Now here I have already did this derivation in my 2-3 marker session, but I don't want to draw this today. I have taken the image for that. Okay, so the diagram you have to draw. Okay, this is a spherical mirror. Ray of light is this is the ray of light which is falling parallel to the principal axis, and after reflection it passes through the focus of the mirror. Okay, now you have to join the center of curvature and the point of reflection. Then this will be angle of incidence and this will be angle of refraction. Okay, so this angle is angle of incidence, this is angle of reflection, and if you add both the angles you will get 2 theta, and this is the parallel line, this is the bisector, so this angle will be 2 theta. Similarly, this is the parallel line, this is the bisector, this angle is theta, then this angle will be also theta. Okay, alternating angle. Both are alternate, but one has bisectors are different. That's why these two angles are different. So from this diagram, only thing you need to care about these triangles and these angles. These angles are important. Without these angles, you will not be able to answer it. Remember that these are not 2 thetas; they are theta theta. And adding these two angles gives you 2 theta over here, and one single angle gives you theta over here. Okay, do not mess up with the diagram. I have seen they just draw some random lines and try to derive it, which if the diagram is wrong, you will not get any marks. Okay, if you are not able to draw the diagram, do not attempt this question. Simple, right? Now let's see what you have to do. So first of all, you consider the triangle CMD. From the triangle CMD, okay, what you have to do, you have to find the sine of this angle. Okay, sine of theta. What is sine theta? Sine theta is actually perpendicular by hypotenuse. Okay, so here if you see that, or let me do not find sine theta. Sine theta can be complicated. Let's find tan theta. Tan theta will be easier. Okay, sine and tan, there is not much difference. So tan theta is perpendicular by base. So MD is perpendicular for this angle. MD is perpendicular and base is CD. Okay, so tan theta is MD by CD. Okay. What about this triangle? Now let us consider the triangle FMD. Triangle FMD. From this triangle we get tan of 2 theta. So tan of 2 theta is MD divided by FD. MD divided by FD. Now for paraxial rays, paraxial means the ray is very close to the pole. So even though we are drawing it large, actually the point M is very close to the point P. Okay, so for paraxial rays, okay, D is almost equals to P. So D and P are almost same. Therefore, MD equals to MP does not matter, and CD equals to CP equals to R, and FT equals to FP equals to F. Okay, so FP is what? FP is the focal length, CP is the radius of curvature. This D point is very close to P, so they are almost coinciding, so we can say that MD is equals to MP and this. Now also theta is very small angle. If the angle is, obviously if the point is very close to the axis, that means this angle theta value is also very small. Therefore tan theta nearly will be equals to theta, and tan 2 theta, theta is small means 2 theta will also be small, so tan 2 theta will nearly be equals to 2 theta. Now we have to revisit this equation 1 and 2. Okay, so we can write that, therefore from 1 we get theta equals to MP by R, and from 2 we get 2 theta equals to MP by F. Okay, so comparing putting theta from this equation, we can write 2 into MP by R equals to MP by F. So MP cancels, so we can write F equals to R by 2. Just take inverse on both sides, okay, reciprocal on both sides. So 2 by R equals to 1 by F, or F equals to R by 2. Okay, so this is the derivation. Slightly tricky, but practice, if you practice it, you should be able to answer. Next, write two conditions for total internal reflection of light and mention its technological application. So light must travel from denser to rarer medium. The angle of incidence must be greater than its critical angle between the medium. Okay, obviously well known. Optical fibers are cables used to transfer data using total internal reflection. So the reason that you are able to watch me right now, because of total internal reflection, because the information is being carried from YouTube servers to your phones via optical fiber network. Maybe that fiber is located in your home, or it is basically being transferred to the network. If you are watching it via mobile network, then it is being transferred to the nearest mobile tower, and then it is being transferred as a form of energy to your mobile phone. If you are watching via Wi-Fi at your home, then the Wi-Fi, the data is directly coming to your home till your home, okay, using fiber cables. Okay, so fiber optics basically based on the total internal reflection principle. Next, now we are into 5 marker territory, so we will be going to solve some very important around 11 very important derivation, 12 in fact, not 11, 12 very important derivations. And if you study only these 12 derivations, you should be able to answer 3 questions. Okay, if you want to have more options, you can check my all 5 mark derivation video. There I have done more derivations, but these 12s are very selective, and if you study them, 3 derivations you should be able to answer. State Gauss's law in electrostatics. This answer I have given in the past, so you can check that out. I am not mentioning the Gauss's law again. Derive the expression, not past means not past video. This video itself I have mentioned, right? If you are watching from the beginning, you know. Derive an expression for electric field at a point due to an infinitely long, thin, uniformly charged straight wire using Gauss's law. So we have a straight wire, okay, and we have to apply Gauss's law to find the electric field due to this wire. Do not draw like me, use some scale, makes one parallel line, and then you add like this so that it appears to be a wire. Okay, don't use hand like me. Now you take a point over here, R, and then construct a cylinder. Okay, best is to construct the cylinder, then take the distance. Okay, now you have to write, let us consider a point P at a distance smaller from the straight wire, current carrying wire, and we are trying to find the electric field at this point P. To do that, we have to construct a cylindrical Gaussian surface of radius R. Okay, the line charge density on the wire is given by lambda. Lambda is given. Okay, so Gaussian surface you have to construct. So you also have to mention that in the text. Okay, now what is how to solve it? Obviously you know that the electric flux through the surface is given by E dot ds, and that is equals to, if this length of the cylinder is L, then charge enclosed is lambda into L divided by epsilon naught. That is Gauss's law. Okay, charge enclosed here is line charge density into length of the wire. Okay, now here obviously the wire is being very infinite, we have to take a finite length, that also you have to mention while writing. Okay, now what? Now you have to write that due to symmetry electric field is constant, so you will come out, so E into ds equals to lambda L by epsilon naught. Now what is ds? ds is the curved area of the cylinder. So for a curved area of the cylinder, it is given by E equals to 2 pi r into L. Okay, 2 pi r into L is the area of a cylinder. 2 pi r is the length, and if you multiply with L, you get, basically you can cut it. Okay, then it will become a rectangle. Length will be 2 pi r, and the length width will be L. Okay, from there you can say the area is 2 pi rl, so it will be lambda L by epsilon naught. Okay, obviously L cancels, So we get, see, L was not given in the question because it's an infinite wire. Okay. Now you can leave your answer over here, you will get full marks, but I like to write it slightly differently. 1 by 4 pi epsilon naught 2 lambda upon r. Okay, this is also, you can write any one of them, you will get full marks, no need to worry. Obviously for writing only doing this you will not get 5 marks. There will be a Gauss's law, for that 2 marks will be there. For this derivation you have to explain the diagram and explain the steps. Without explanation you will not get full marks. Okay, so for 5 out of 5 you have to explain the diagram. You can check my 5 marker derivation, there I have explained the everything in detail. Now next, derive an expression for electric field at a point on the outside charged spherical shell using Gauss's law. Again, this can be coming with state Gauss's law again. Okay, so that is also possible, the state Gauss's law, and find the electric field outside a shell. Okay, what will be the electric field inside the shell also can be asked. Don't worry, we will obviously tell you. Gauss's law already I have given. Now here, suppose the radius of the shell is capital R. You are trying to find electric field at a distance, say, first let us draw the outside sphere. This is Gaussian surface. You are trying to find electric field at a distance, at a point P, at a distance small r. Okay, now again same thing. So whenever Gauss's law is there, you have to explain the diagram. That let us consider a spherical shell of radius capital R. We are trying to find the electric field at a distance small r from the shell at a point P, and small r is greater than capital R. You have to mention that small r is greater than capital R. Okay. Now from Gauss's law, let us construct a spherical Gaussian surface. This is a spherical Gaussian surface. Okay, the total charge on the sphere is capital Q. So we can say that E dot ds equals to Q enclosed by epsilon naught. Now again, due to symmetry E is constant, that you have to mention. Due to symmetry E is constant, so we can say E into close integral ds equals to Q upon epsilon naught. Now E into 4 pi r square. Don't make mistake, it will be small r square, not capital R square, and that will be equals to Q upon epsilon naught, or electric field equals to 1 by 4 pi epsilon naught Q upon r square. Okay, electric field inside the surface is 0. Okay, just exactly on the surface will also be 0. Just outside the surface electric field will be, if you put small r equals to capital R, you get the electric field just outside the surface. Okay, from the center till exactly on the surface electric field is 0. Just outside the surface they might add what is the electric field just outside. You just need to substitute small r equals to capital R. Okay, and you can write E equals to E just outside equals to 1 by 4 pi epsilon naught Q upon capital R square. Okay, this is just outside the surface. So this is also possible, they might ask you. Okay, as an extension. Next, derive the expression for electric field at a point on the axis of an electric dipole. So again, the diagram is compulsory. Here we have a remember the diagram. So we are trying to find electric field on the point on the axis, say at a point P. The distance from the center or midpoint of the dipole is small r. We are trying to find here the dipole, the total length of the dipole is 2L. This is plus Q, this is minus Q, and this distance is L, this will be also be L, right, with the midpoint. Now electric field due to the positive charge, say this is E plus, and electric field due to the negative charge, say this is E minus. Okay, both are at a different distance, so their forces, electric field will also be different, right? And electric fields generally gets added vectorially. Obviously in this case, because they are opposite direction, it will be simple subtraction, but if they are acting at an angle, you have to use vector method of addition. Okay, anyway, so what is the electric field due to the positive charge? So the electric field due to a charge is given by 1 by 4 pi epsilon naught q upon the distance. Now here, what is the distance square, or sorry, not distance, distance square. What is the distance over here from the positive charge? Distance is only this much. This distance is not given, by the way. If you see the distance from the midpoint, which is given r, and distance of the length of the dipole is given as 2l. Okay, so this is l, and if you subtract l from r, you get this distance. Okay, do not make any other mess. This is the shortcut way, this is the easiest way to do that. If you say that this distance is smaller, then you have to add, and that will be a very difficult problem to solve at the end. Okay, but this way it will be very easy to solve. That's why exactly this way we are solving. What about the negative electric field? Negative electric field is 1 by 4 pi epsilon naught q by r plus l whole square. Okay, so this distance is r, from the negative charge r plus l, so it will be r plus l whole square. So what is the total electric field? The net electric field is given by E plus minus E minus y, because obviously because they are in the opposite direction, and positive charge being near, the total electric field due to the positive charge will be more, right? So 1 by 4 pi epsilon naught is common, even q is also common. Okay, both have the same q and 1 by 4 pi epsilon naught, only this thing is different. So if you put that, you will get 1 by r minus l whole square minus 1 by r plus l whole square. Now you have to simplify this, so you can write q by 4 pi epsilon naught, the multiplication will be r minus l whole square into r plus l whole square, or we can say that r minus l into r plus l over whole square, and this will come over here, cross multiplication, right? So r plus l whole square minus r minus l whole square. So you get this as, what is this? So net electric field will be q by 4 pi epsilon naught. Now if you remember this, there is a formula, a plus b whole square minus a minus b whole square, which is 4ab, here 4 into rl, and this one will be a minus b into a plus b, which is same as a plus b into a minus b, that is a square minus b square, so r square minus l square, and obviously there was a whole square already present, so that will be also there. Now let us simplify this. Let us write like the way I am writing, 1 by 4 pi epsilon naught okay, 2 into q into 2l into r. Okay, exactly the way I am doing, do it like that. Okay, and r square minus l square whole square. Now also you have to remember that this is the dipole moment of the dipole. Okay, q into 2l is the dipole moment, so we can write net electric field is 1 by 4 pi epsilon naught 2 p r by r square minus l square whole square. Now for r greater than l, very greater than l, because the definition of dipole says that the distance between the dipole is very small. So distance between the dipole is very small means any distance that we are measuring has to be higher than this distance, and that has to be very higher than this distance. So r very greater than l, we can ignore this l square term, because if l is small, then l square will be much smaller. Okay, so we can write E net equals to 1 by 4 pi epsilon naught 2 p r divided by r to the power 4. Obviously square is gone, r square to the power square is r to the power of 4. So here we get r cube, this cancels, and we get E net equals to 1 by 4 pi epsilon naught 2p upon r cube. Okay, so this is the expression for net electric field. You can write in vector form as well. Okay, electric field and dipole moment are in the same direction. So but that is not required. If you are just looking for full marks, that is sufficient. Okay, do not overextend it. Now next, derive the expression for electric field at a point on the equatorial plane of the dipole. Many students find this derivation slightly difficult. Okay, the other one is relatively easy. So here the distance we are measuring from the midpoint again. So this is around the midpoint. So let us construct a line over here. This is the line over here. Okay. Now this is L, this is L. Next you have to find the electric field, say at a point P on this equatorial plane. So join them, and so this is say positive charge, this is say negative charge. Now electric field, this distance is r. Okay, now what we are trying to find electric field at P. Electric field at P means there is a positive charge. It's the positive charge, the electric field will be always away. Electric field due to positive charge is always away, because how to find the direction of electric field? This is positive. If you keep a positive charge over here, what will be the direction? Repulsion, so away. If you keep a positive charge over here, what will be the direction of the force? Attractive. Attractive force means it will always be towards. Okay, so towards means this will be the direction of force. Okay, so this is E plus, this is E minus. Now this is not over, because it's a dipole and this is equatorial plane. This angle will be theta, both angles will be theta. It will be an isosceles triangle, and in case of isosceles triangle, the base angles become same. Now if you draw a parallel to the base, you will see that okay, if you draw a parallel to the base, this angle and this angle will be same. Okay, and this angle and this angle will also be same. Okay, one will be alternate angle, one will be similar angle. Okay, so this is the similar angle, this is the alternate angle. So both angles are same. Now if you take x component, or this is the x-axis and this is y-axis. If you take the x component of both E plus and E minus, they will be same value. Why? Because both of them are making an angle theta with the x-axis. But when you try to find the y component of these two forces, these two fields, okay, E plus will be positive, E minus will be minus, negative. Okay, because it is in the opposite direction. So y components will vanish, only x component will remain. Now whatever I am saying, you have to write it in your own words during the exam. Okay, so electric field, first of all you have to write that electric field due to positive charge is equals to electric field due to negative charge, because both are equidistant. So this distance is square root of r square plus L square, Pythagoras theorem. This is r, this is small l, so r square plus L square. Similarly, this will also be r square plus L square, Pythagoras theorem. Okay, and this will be equals to modulus of electric field E. Okay, this will be modulus of electric field E. Right, now what? Next you have to be so this is electric field E, and we are saying this is C. Modulus of positive and negative both will be same. Now x components will be there, y components will cancel. So net electric field, the net electric field will be x component of plus and x component of y, x component of plus and x component of minus. Okay, now both are magnitude wise same, because distances are same, magnitude of the charges are also same. So this will be the case. So it will be 2E cos theta. Okay, E net is only along x direction, y direction electric field is 0. They cancel each other. Okay, both of them same magnitude, that's why I am writing EE. You can write one more line, E plus, E minus, then write EE, and then you can add it. But what is that electric field? Electric field is very simple. 1 by 4 pi epsilon naught into electric field is Q upon R square plus L square whole root whole square. So simply, so what we are doing, square root of R square plus L square whole square. So square root is gone, simply R square plus L square is there. Okay, now what? Now we have to write the value of cos theta. So cos theta means this angle is theta, this is perpendicular, this is base, this is hypotenuse. Okay, cos theta is base divided by hypotenuse. Base is L, okay, and hypotenuse is square root of R square plus L square. Okay, now let's simplify. 1 by 4 pi epsilon naught. Sir, why you are not cancelling? We will not, because we need these two. This 2 is very helpful. Q into 2L divided by R square plus L square to the power 3 by 2. Okay, now again Q into 2L is what? Q into 2L is the dipole moment. You have to show that. I have done it in the previous derivation, so that's why I am not doing it, but you have to, you will get only one derivation, so you have to write that. Next what? Next again the same approximation, that R is very greater than L, so this L square you can ignore, so you have to do R square to the power 3 by 2, so 2 cancels, you get R cube. Okay, so that means E net x component equals to 1 by 4 pi epsilon naught P upon R cube. Okay, now this is not over for equatorial plane. For equatorial plane you have to write the vector notation as well. It is not required for axial plane, but for equatorial plane this is compulsory, because the dipole moment is from negative to positive, the net electric field is from the opposite direction. That's why there is a negative sign here. Negative sign represents electric field and dipole moment are in opposite direction. So this negative sign has to be there in the final answer. Now next, define electrostatic potential due to a point charge and arrive at the expression of electric potential due to a point source charge. Now this definition, sometimes it comes, sometimes it does not. This is not as important as last year, because last year this question came in the first exam as well as in the second exam. So my opinion, this may not be coming this year, but don't think that it will not come, because in the past there are many instances where your PU board has given question back to back year, so this question still might come, so you have to practice this question as well. Here we have a charge, say capital Q, we are trying to find electric field at a point P. Okay, this is the point P at a distance small r. Now to do that, we have to take some intermediate point A and B at a distance, small distance dx apart, and we have to go till infinity. With the definition of electrostatic potential is that the work done to bring a unit positive test charge from infinity to a point in the field. So basically we have to start a unit positive test charge from infinity, and if we bring that test charge from infinity till this point P, whatever work we will do, that work is basically our electrostatic potential at this point. Now infinity is not beyond our scope, so that's why we have to take 2 points which are very close to each other and which is neither infinity nor exactly at this point. So it is between infinity and this point, some point. Okay, so this is the distance, and the distance, average distance of these 2 points from the source charge is x. Okay, Obviously dx is very small, so it does not matter you are showing this distance from A or from B. Now let us consider what is the force that is acting. Now here I have seen some weird derivation methods. Some colleges teach that. Okay, teachers generally give the marks, but if it is not that proper, if you are not writing this properly, they might deduct marks. The method I am going to show you is perfect and you will get full marks if you do that. Okay, so here first of all you have to write what is the external force, what is the internal force acting on the charge. The internal force, so if you keep a unit positive charge at A1, if you keep a unit positive charge at A, okay, what is the force acting on that? Internal force, the force acting on that charge is basically Coulomb's law, which says that 1 by 4 pi epsilon naught capital Q into 1 divided by the distance square, that is x square. This is the internal force due to this charge on the positive charge. It can be attractive, it can be repulsive, does not matter, but this is the internal force. Now if you want to bring a charge, okay, of +1 from A to B, then you need to apply a force which is exactly opposite to that of external force. With the external force that we have to apply to bring the charge, in fact you have to apply because you are doing it in the exam. So the force that you have to apply to bring the charge from A to B has to be in the opposite direction. So that is the external force has to be opposite of that, the internal force, and that is equals to minus 1 by 4 pi epsilon naught Q by x square. Now here student use some weird dot product cos theta minus 1, not required, because it is simply, you can simply say that okay, the force is basically from Coulomb's law. This is coming from Coulomb's law. This is internal force due to the source charge, so we have to apply external force which is exactly opposite to that of the internal force, that is minus. That's it. No cos theta, no complicated business over there. Okay, because they are saying this is direction, this is the direction of force, cos theta 180 degrees, which not 100% correct. Okay, so this is the reason that the external force that you have to apply to bring a test charge has to be opposite that of the internal force. Okay, that is why it is negative, nothing else. Now whenever we say work done in physics, we mean that the work is being done by us. Okay, our work is being always positive, anything else is doing work is negative. If the field itself do some work, that is negative. Okay, that is considered negative in physics. Our work, because we are important, right? We are doing some work, that means we have to get paid for that. So that means if you are doing hard work, you should expect a good marks in exam. So that's why our hard work is important. Field work we will generally take negative. Okay, so this is the negative thing. So the work done to bring the charge from A to B, okay, the small work done to bring the test charge from A to B, if that work is represented by dW, then it will be equals to the external force that you have applied times the displacement. Work done is force into displacement, right? So this is the small work done. Or to calculate the total work done, what you have to do to calculate the total work done, we have to integrate this external force and dx, and then we have to extend it from infinity to our point R. Okay, so this is a small work done. Now why we have to take this route? Because electric force is not constant throughout this journey. Okay, so as it is at infinity, electric force was 0 and it is slowly coming towards this, the forces keep on increasing. So this is a variable force problem. That's why integration is only way to solve. Okay, if it is a constant force, we just simply need to use force into displacement, but it's not constant force. So total work done, now we have to put these values and simplify. Okay, so work done is given by minus 1 by or Q by 4 pi epsilon naught. This is constant, so that's why we are taking them outside integration. Now integration infinity till R, final to initial to final. Okay, and it will be dx upon x square. Okay, dx upon x square. Okay, so that will be minus q upon 4 pi epsilon naught integration Okay, dx by x square, you can do the integration yourself. Oh my god, sir, this is a very difficult integration, is it? Minus 1 by x. We have to do integration of 1 by x square and we will get minus 1 by x. It is not difficult, it is easy. Now this minus will come out and it will be common. So we get q upon 4 pi epsilon naught, and you get 1 upon r minus minus plus, sorry, not minus minus plus, what I am saying, there will be a minus sign. This minus coming out, that's why the outside minus is gone. This minus comes out of the integration. You can have one more sign if you want, but anyway, okay, so this is upper limit minus lower limit. So it will be obviously work done is given by q upon 4 pi epsilon naught into 1 by r. Okay, this is work done. So this work done is actually equals to electric potential. So electric potential is 1 by 4 pi epsilon naught. Sir, what happened to the q? I am writing here. Okay, so this is q by r. This is the expression for electric potential due to a point charge. Very common, one of the most asked question from this chapter. Next, derive an expression for effective EMF and effective internal resistance of two cells of different EMFs and internal resistances connected in series. So series, parallel and Wheatstone bridge, these three, all three are important from the current electricity chapter. Any one of them will be coming in this year. Epsilon 1, R1, epsilon 2, R2, okay, and they are connected across an external resistance, say capital R. Practice all three derivation. Okay, and equivalent means equivalent is only one cell and one internal resistance. Okay, so two cell means obviously one battery with a small resistance which is called a cell. So it has this is internal resistance, this is the EMF of the cell. So you have to find the equivalent EMF and equivalent resistance. Now in series combination, I always say, remember this thing, current is constant, current constant, charge is constant, voltages are different, okay, but in this case because two batteries are there, so voltage across this one not super important, but anyway we will see how to calculate that. Okay, the voltage across the resistance is important, voltage across resistance, say V. Okay, now we have to find this current and then the voltage across the resistance should remain same. The voltage across the resistance should remain same no matter what. Okay, current AN should be same. Now let us apply Kirchhoff's law in this loop and try to find what is happening. So if you apply Kirchhoff's law in this loop, we will get I into R, okay, equals to current into resistance, current into resistance equals to, sorry, not equals to, plus we have one more resistance over here. Okay, and in case of cell, remember whatever current is exiting, same current should come back always, conservation of charge. So the current through this R2 will be I, current through this I, R1 will also be I. Okay, so plus I small r1 plus I small r2 equals to epsilon 1 plus epsilon 2. This is applying Kirchhoff's law. This is applying Kirchhoff's law, Kirchhoff's voltage law. Okay, or now I into R is the voltage drop across this resistance. This is the voltage drop across this resistance. Okay, so you can say this is the voltage drop. So V plus I into R1 plus R2 equals to epsilon 1 plus epsilon 2, or V equals to epsilon 1 plus epsilon 2 minus I into R1 plus R2. This is my equation number 1. Now if you apply Kirchhoff's law in the equivalent circuit, this is normal circuit and this is equivalent circuit. Okay, for equivalent circuit the same calculation can be done again. So you get IR plus IR equivalent equals to epsilon equivalent, or V equals to epsilon equivalent minus I into R equivalence. Now if you compare these two equations, this is equation number 1, this is equation number 2, it will be very easy that this must be the equivalent EMF. So comparing 1 and 2, we can write epsilon equivalent equals to epsilon 1 plus epsilon 2, and R equivalent is equals to R1 plus R2. Even though this is easy, this is the most common asked question. Apart from Kirchhoff's law, series combination of cell is also very, very important. Parallel combination did came, but the number of occurrences is less. So anyway, this might come, you might say that, sir, you did not do parallel and it came in your exam, what to do? So let's do the parallel one as well. So parallel combination is same. Okay, in parallel combination epsilon 1 R1. So here the batteries or cells are connected in parallel along with the external resistance. So epsilon 2 R2, this is R. Now voltage in all these cases are same. Voltage in all these cases are same, and the equivalent cell in this case is, so remember, no matter what thing you are doing, the equivalent circuit is always similar. Okay, no matter you are doing resistances, capacitors, because equivalent will only have one thing, not multiple things. That is the beauty of equivalent cell. Now suppose the current through this is I1, current through this is I2, the total current is I. Okay, if somehow we can find I1 and I2, we can find the voltage V. Okay, so our target is to find I1 and I2. So first we will use the outer loop and we will find. Okay, so we will get I into R is always same. Okay, I into R, and here we are going in this direction, so the current that is coming back is also I1, so I1 R1, so plus I1 R1 equals to epsilon 1, or I1 R1 equals to epsilon 1 minus V. This is the voltage V. Okay, so that's why we are writing it like this. So from here we can write I1 equals to epsilon 1 by R1 minus V by R1. Similarly, I2 can be calculated epsilon 2 by R2 minus V by R2. Right? If you apply 1, you get this. Similarly, you can apply the same loop rule in the second loop and you can calculate the I2. So adding these two, we get I1 plus I2. Okay, adding these two, we get epsilon 1 by R1 plus epsilon 2 by R2 minus V gets common, we get 1 by R1 plus 1 by R2. Okay, our target is to find this V always, no matter what you are doing, our target is to find this V. So I1 plus I2 is equal to I, so I equals to epsilon 1 by R1 plus epsilon 2 by R2 minus V into 1 by R1 plus 1 by R2. Okay, so simplifying, we get V into 1 by R1 plus 1 by R2 equals to epsilon 1 by R1 plus epsilon 2 by R2 minus I. Okay, now divide it, you get V equals to epsilon 1 by R1 plus epsilon 2 by R2 divided by 1 by R1 plus 1 by R2 equals to minus I divided by 1 by R1 plus 1 by R2. Okay, so this is the voltage across the battery combination. Now similarly so voltage equation for the equivalent will be same as the last case, so we can write voltage for equivalent circuit. For equivalent circuit we can write epsilon equivalent minus I into R equivalent. Right, we have done that in the same way. You can do this way. Okay, one more line you have to write. I just keep that because I am running out of space. So this is the equation, or you can write this as epsilon equivalent minus I divided by 1 by R equivalent, right? So this was in the multiplication, so we can write 1 by R. So if you compare this, epsilon equivalent is very simple, epsilon 1 by R1 plus epsilon 2 by R2 divided by 1 by R1 plus 1 by R2. Do not simplify, this will be the answer. You can leave your answer over here. Okay, simplification is not required, and 1 by R equivalent equals to 1 by R1 plus 1 by R2. So resistances are adding parallelly and voltages are adding something. This formula, if you remember, no, this parallel combination based numerical questions came multiple times. So if you see a question where parallel combination based question is coming, use this formula. This will be very, very helpful. Now we are obviously not doing any numerical question because this is for the students, those who have not prepared or just revising. If you want to practice numerical question, then you have to check my live. I will be doing a lot of lives, so don't miss out on them. Okay, so Wheatstone bridge, it came last year, but it might come this year as well. So if it is coming, very easy derivation. So P, Q, R, S. This is the galvanometer G. Now suppose a current I1 is passing over here, a current IG is coming over here. Okay, so current I2 is going there, I3 is going there, and I4 is coming there. Okay, no need to apply Kirchhoff's laws here as of now, especially the Kirchhoff's current law. You just mark them I1, I2, I3, I4 and this IG. That is fine, okay, because eventually what we will be saying that for balanced condition of Wheatstone bridge, so we are finding the condition for balance. Now for balanced condition, what they have to achieve? For balanced condition, when we will say that the bridge is balanced, the balanced condition is when we say that galvanometer current is 0. So for IG to be 0, what conditions it has to obey? That is our target to do. Okay, now what to do? Obviously we will be first apply Kirchhoff's law in this loop. Obviously if IG equals to 0, if you see, that means no current is passing in this direction, so I1 and I2 should be same. So I1 must be I2 and I3 must be equals to I4, right? So I1 must be equals to I2 and I3 must be equals to I4. Now if we apply Kirchhoff's law in the loop, say A, B, C, D. So we will apply in A, B, D, A loop. Okay, in loop A, B, D, A, applying Kirchhoff's voltage law. Kirchhoff's voltage law or Kirchhoff's loop rule, whatever you say. I am comfortable with Kirchhoff's voltage law. Applying Kirchhoff's voltage law in the loop ABDA, we get I1 into P plus IG into G plus minus I3 into R. Why minus? Because whenever you are going in a loop, remember that the direction of the current is important. Okay, so when you are going in this direction, 1, 2, 3, 4. So 4 and 1 are same. So this direction current is positive, this direction current is positive. Okay, this direction we are going from here to here, but current is going in the opposite direction. That's why it is minus. And as there is no battery connected here, so it will be equals to 0. Now IG obviously is equals to 0. So from there we can say I1P equals to I3R. Okay, obviously bracket you have to write IG equals to 0 or P upon R equals to I3 upon I1. Now you can do the same thing for B, C, D, B loop, or you can write similarly from BCD B loop, okay, because you have already established same thing can be applied for this loop. So if you see that P by R equals to I3 by I1, okay, so similarly Q by S equals to I4 by I2. Okay, this resistance divided by this resistance equals to this current divided by this current. Similarly, this resistance by this resistance would be this by this. Okay, now what is I4? I4 is equal to I3, so we will write it as I3, and I2 equals to I1, so we will write this as I1. This is my equation number 1, this is my equation number 2. Comparing right hand side on both equation, we can say that P upon R equals to Q upon S, or P by Q equals to R by S. Okay, this comes over here, this comes there. P by Q equals to R by S. This is the condition for balance of Wheatstone bridge. So if this divided by this equals to this divided by this. Okay. Derive the expression for magnetic field at a point on the axis of a circular current loop. This derivation is super important this year from this chapter. Okay, so here we have a current carrying loop. We are trying to find a current element dl. It is carrying a current. The radius of the loop is capital R. Okay, and we are trying to find magnetic fields at a point P, which is at a distance x. Okay, if you join these 2 points, this will be the distance r, and that is nothing but square root of r square plus x square from Pythagoras theorem. Okay, the angle that this dl makes with this angle vector is 90 degrees, so theta equals to 90 degrees. This angle will be phi, and one more thing you have to remember, that this magnetic field will be making an angle phi with this x-axis. Okay, now this can be proven, but I am not doing that. This is not out of scope of this derivation. Okay, so this diagram you have to remember, okay, exactly the way I have drawn. Now next word, you have to apply Biot-Savart law. From Biot-Savart law, we can say that this small magnetic field dB is given by mu naught by 4 pi I dl by r square. Now you might say, sir, where is the sine theta? So I mentioned theta is 90 degrees, so sine theta is 1. Do not mark this as theta. This is a different angle than theta. Okay, in Biot-Savart's law we have a sine theta. That sine theta is 90 degrees, and that is different than this phi. So that's why do not mark this angle as phi. Many textbook, many teachers also might use this as theta, but do not do that. You have to mark them as phi. Okay, so this is the dB equals to ideal r square. Now one important thing is that because it's a circle, due to symmetry, all y component will cancel, only the x component will be there. Okay, so only the x component will be there, so we can say that the dBx we need to find. And what is dBx? Obviously dB cos phi, dB cos phi. That's it. Now put the value mu naught by 4 pi, okay, IDL by r square. And what is cos phi? If you come back to this triangle, cos phi is the base by hypotenuse, so it will be r by small r. Okay, we are not putting the value yet, we are waiting. We will put that value back as soon as we have simplified this. Okay, divided by r cube. Okay, now what? Obviously this is due to a small portion, dl. So to find the total magnetic field along the x component or x component of the magnetic field, we have to integrate it. Okay, dBx. Now integration means here only dl will be integrated, remaining stuff are all constant. Okay, so we get magnetic field along x component mu naught by 4 pi IR by r cube integration dl. Now integration dl, here it will be close integration. Why close integration? Because starting point and ending point has to be same. Okay, so and a close integration of a circular wire, it will just result in the perimeter of the circle, because it's a close integration. So close integration means you are just basically adding all these small dls, which is basically the circumference of the circle. So you can write this as mu naught by 4 pi, okay, IR by R cube into 2 pi capital R, okay, or mu naught by 4 pi 2 pi will be cancelled, so mu naught by 2 will be left, mu naught by 2 will be left, and you get I R square by R cube. So we have reached our final destination, okay. So this will be Bx equals to mu naught by 2 I R square capital R square plus x square to the power 3 by 2. So here we had square root, here we had cube, so it will be to the power 3 by 2. This is the expression for magnetic field at a distance x or on the axis of a circular coil. If they add what will be the magnetic field at the center, then we have to put x equals to 0 and simplify it. But that never came, and I hope that will not come, because the derivation itself is very long, okay, and you have to explain the diagram as well and why the y component cancels. These are the important point that you have to write. Find the force per unit length between two parallel current carrying wires. Now this derivation did came last year, so chance of this coming less, but there are mainly two derivation from this chapter. There might be in a mood that I want to repeat a question, so do not ignore this as well, okay. The other one is very important this year, but this might come as well, so why not practice? And some of you may be watching this video for second exam. So second exam, you might say, sir, first exam that came, so maybe second exam this one will come. Yes, very much possible. So yes, let's practice this one as well. So distance between the wire is I, and you have to take some arbitrary length. Diagram, remembering diagram actually helps. 60% derivation is 60% done, okay. So this is I1, so magnetic field due to this is say B1, and magnetic field due to I2 is say B2, okay. So this will experience a force here, so force on 2 due to 1, and this will experience as a force not in this direction, so force on this say F21, and force on this will be F on 1 due to 2. That how it is being named, force acting on 1 due to 2, force acting on 2 due to 1, okay. So this is our wire number 1, this is our wire number 2, both are carrying current in the same direction, okay. So magnetic field, what is the expression for magnetic field due to a current carrying wire? It is mu naught by 2 pi I upon the distance. Remember, this is the basic that you have to remember. Magnetic field due to a current carrying wire is mu naught by 2 pi I1 upon d, okay. Now what is the force acting on it? Force acting on it will be not force, B21, force acting on 2 due to 1, that will be magnetic field into current into the length. Now here both are very long, so we are taking a certain length of the wire on which the force is acting, okay. So eventually you have to eliminate this L, because this L is arbitrary, we are assuming this L, okay. So now we can say that this is mu naught by 2 pi I1 I2 by d into L. Similarly, F12 can also be proven that mu naught by 2. You have to show that B1 is done, B2 you have to show B2 is mu naught by 2 pi I2 by d, okay. B1 is due to this wire, B1 is due to this wire, B2 is due to other wire, Okay, so it will be again I1 I2 upon D into L. Okay, so as you can see, both forces are same. So F21 equals to F12 equals to Fc. Now here the magnitudes are same. Okay, magnitudes are same. Okay, that's why we are writing that. Direction wise, if you write in terms of direction, they will be opposite direction. Okay, so from there we can say that this force F equals to mu naught by 2 pi I1 I2 by D into L, or force per unit length, which is given by F by L, that is given by mu naught by 2 pi I1 I2 by D. This is the expression. Now sometimes they might ask also define ampere from this. So to define ampere, you have to mention if I1 equals to I2 equals to 1 ampere and D equals to 1 meter, then force per unit length will be equals to 2 into 10 to the power of minus 7 Newton per meter. So there is a case where if you forget this, you have to write in terms of words. Okay, this is how do you remember it, and then you have to write it in terms of what, that if two parallel current carrying wire, each carrying current 1 ampere kept at a distance of 1 meter, then the force acting between them will be force per unit length between the wire will be 2 into 10 to the power of minus 7 Newton per meter. Don't make a miss on that. The topper, one of the topper last year, they made a mistake. They did not mention Newton per meter. The marks was deducted, but fortunately he or she wrote extra question, and that was considered as an extra. Okay, so don't miss out on that. Newton per meter, you have to mention that. Now what is a rectifier? Very important. Full wave rectifier is the most important. Half wave rectifier is also second most important. What is a rectifier? Explain the working of full wave rectifier. So diagram is compulsory. Okay, a rectifier is an electronic device that converts alternating current AC into direct current. Almost done, just a few minutes. During the positive half cycle of the AC input voltage, the upper half of the transformer secondary winding becomes positive, diode D2 becomes forward biased and conducts, allowing the current to flow in the, through the load resistor RL. Diode D2 is reverse biased and does not conduct. Okay, so this is the diagram. So in the positive half cycle, this diode conducts. In the negative half cycle, this diode conducts, and in both cases the current is being allowed to the load resistance in the single direction, because current is flowing in this direction, current is flowing in this direction. This is a center tap method. Okay, this is called center tap method. Okay, during the negative half cycle of the AC voltage input, the lower half of the transformer secondary winding becomes positive diode. D2 becomes forward biased and conducts, while the diode D1 reverse biased and does not conduct. Current again flows through the resistor in the same direction during the half cycle. This is the diagram. You do not need to show two forms of input. Single input is sufficient as long as you show which current is due to which. Okay. Now next, what is a half wave rectifier? Explain the working of half wave rectifier using the diagram. So half wave rectifier is an electronic circuit that converts alternating current into AC to DC, but only during one half, not due to the full half. The other half cycle is blocked, so only half of the AC waveform is used. This is the diagram, simple diagram. Only one diode, one resistance through which current is being flowed. Okay, during the positive half cycle of the AC input, the P side of the diode is positive with respect to the N side. The diode becomes forward biased and conducts current. Current flows through the load resistor in one direction and the voltage across the load is positive. During the negative half cycle of the AC input, the P side of the diode becomes negative. With respect to the N side, the diode is reverse biased and does not conduct, so no current flows. So this is the input, this is the output. Now this is the end of today's lecture, but remember that do not cut on any one of the question from the questions that I have done, okay, because this is very specific. If somehow any new question comes, you will not be able to answer those questions, so do not cut out on these. These are the minimum questions, and if you prepare all these questions, you should be easily scoring 50 plus marks. Okay, and obviously the PDF of this lecture will be available in our WhatsApp channel, so don't forget to join the WhatsApp channel if you have not yet. Also subscribe and give it a thumbs up if you like this video. Okay, and if you are watching this video up to this point, then definitely it's a thing that you should leave some comment in the description box that I have completed it. Okay, I have completed it. Please mention that, so that I will be knowing that how many of you have completed this lecture completely, right? I'll be back with more lives and more important revisions very quickly, because obviously your exams are there on exactly on the door. So don't forget to join me during the live sessions. Till then, bye.